Welcome back, Pre-Calc. We're going to continue on with circles and ellipses today. So we're going to be writing the equations of circles and ellipses. I've got the checklist on the screen. You know what to do from here. So before we get started, quick question for you. I've got kind of the standard equation of an ellipse here, and I would like to know, does this graph have a horizontal or vertical major axis, and why? So this graph is going to have a horizontal major axis because remember, for ellipses, A is always greater than B, and since A is underneath the x variable, in this case our major axis is going to be horizontal in the x direction, okay? And remember, our Pythagorean identity, relation for ellipses is a squared equals b squared plus c squared, okay? So just a little recap for you. Okay, so I'm going to force a pause on your screen. You don't need to copy everything, just go ahead and write down the endpoints of the axes for me. All right, so if you notice, I've went ahead and plotted the endpoints. So for this ellipse, will your major axis be horizontal or will it be vertical? It's going to be vertical, right? Because you've gone more. You can see your endpoints here. This is a longer distance here than that, right? Good. So our larger number will sit underneath the y terms, correct? And if we go right in between the two purple dots or the two yellow dots, that will give us our center. So our center in this case is the origin, right? HK is going to be 0, 0. So I'm going to go ahead and put the y squared first. And again, since the center is the origin, I can just put y squared and x squared. And now I just need to figure out the denominators. Well, for the y's, I've gone plus 8 and minus 8 from the origin to get to the endpoints. So 8 squared is going to be 64, right? And to get to the endpoints of the minor axis, I've gone plus 6 and minus 6 from the center, and 6 squared is 36. So that's it. That's the equation of our ellipse given the two endpoints of the major and minor axes. All right, I'm going to force a pause on your screen. Go ahead and copy example 2 for me. So for example 2, we know that the foci are plus or minus 3, 0, so negative 3, 0, and positive 3, 0, and that the major axis has a length of 12. So would you say the major axis in this case is going to be horizontal or vertical? It's going to be horizontal. It has to be, your foci lie on the major axis, right? So it's got to be in the same direction as the foci, which I've got plotted here. So if the major axis has a length of 12, I can tell my center is certainly the origin again, right in between those purple dots. So that means I've gone 6 in either direction to get to the endpoints of my major axis, okay? So 1, 2, should be about here and here. That should give me a length of 12. Again, 6 in either direction from the center, okay? So that means that A must be 6, right? And I know from my foci that C must be 3 because I've gone plus or minus 3 from the center to get to my foci. But I don't know B, right? So to find B, let's use our Pythagorean relation, a squared equals b squared plus c squared. Well, A is 6, so 6 squared is 36. B squared is actually what I'm looking for. Plus c squared, c is 3, so c squared will be 9. So b squared is going to be 36 minus 9, which is 27. And remember, b squared is all I need for my formula. So my final answer, I've got just x squared, because again the center is the origin, over a squared, so remember a is up here, so over 36, plus y squared over b squared, and that was 27, equals 1. And that is the equation of the ellipse. All right, I'm going to force a pause on your screen. Can you copy what I have? And then we'll do this one together. Okay, so I have that the major axis endpoints are at 1, 12 and 1, 0. So I've got those plotted, and then my minor axis length is 10, okay? So I think first what I want to do is go ahead and find the center, HK. And the center is going to be the midpoint between the two yellow dots, right? Which is just, you want to average your x's and average your y's. So if I take 1 plus 1 divided by 2, I'm still at 1, right? And then if I average 12 and 0, I should be at 6. So my center should be 1, 6. Now take a look at the length of your major axis. we have gone from y equals 0 to y equals 12, right? So the major axis has a length of 12. So I'm going to put L equals 12 there. Let me move myself so you can see that. Okay, so if the length is 12, that means that from the center, I've gone plus 6 and minus 6, right? So that means that a squared will be 6 squared, which will be 36, right? My minor axis has a length of 10. That was given. That means I've gone plus 5 and minus 5, right? So b squared will be 5 squared, which will be 25. And now we've got all the pieces we need. So I'm going to start with my y's. So y minus, grab the y coordinate of the center, squared. And then I've got that over 36. Remember, my major axis here was vertical. We went more in the y direction than we did the x. Plus x minus, now grab your x coordinate of the center, squared, all over b squared, which was 25, equals 1. And that is our equation. Okay, so last time we talked a bit about eccentricity. I gave you the formula. I put it back up here, that E is C over A. And what eccentricity measures is like how off-center it is, okay? So the larger your E value is, the more kind of oval-like your ellipse is. The smaller it is, the more circle-like your center is, okay? So the Earth's orbit has a semi-major axis of A, and a semi-minor axis of B. And we want to calculate the eccentricity of the Earth's orbit and then interpret our results, okay? So for eccentricity, I need C and A. I have A, but I don't have C. But I can use our formula of A squared equals B squared plus C squared to find B, right? So let's plug these in. I'm going to have approximately 149.598 squared equals B squared. Plus, we have B, 100 plus C squared. So C is what we're looking for. I'm going to go ahead and grab my calculator and simplify C for you. Okay, so I am getting that C is about 2.507. So now let's go ahead and calculate the eccentricity. So remember, eccentricity is C over A, so I've got 2.507 over A, which is 149.598, and a calculator tells me that that is approximately 0.017, and that is quite small, right? That is pretty close to 0. So the interpretation here is that the Earth's orbit is actually fairly close to a circle. It's not super oval-like, okay? So that is what eccentricity means. Again, the smaller it is, the closer to 0, the closer the shape is to a circle. The larger E is, then the more off-center it is. All right, so I have a little video clip here to kind of show you how eccentricity changes as your foci move out. So I want you to pay attention to the A value and the E value. I'm going to go ahead and play it. So you can see that as you are becoming less like a circle, right, your E value is getting larger and larger, your eccentricity is getting larger, then coming back, now your eccentricity was 0. Okay, so so take a look at these celebrities' rings. You can see quite the difference between Blake Lively's ring and Haley Baldwin's ring. Can you tell maybe which one has the larger eccentricity? Okay, can you see here that Haley's is less circle-like, like it's more oblong? And that is actually one of the ways that oval rings are valued at, okay? So typically the more circular like it is, oftentimes if everything else is the same, those are going to cost more, whereas if it's elongated more, that will oftentimes make it a little cheaper, you know, $500,000 versus 2. All right, I will see you all in class.